Now we're going to actually have the opportunity to use our theorem that we just saw to evaluate some of these following limits. We notice that we're taking the limit as x goes to infinity of 2 minus 1 over x, and here is a picture pretty much of that function. Now, according to properties of limits, we can go ahead and break these up into their own limits. So we have the limit as x goes towards infinity of 2 minus the limit as x goes to infinity of 1 over x. And from our theorem, we said that the limit as x goes towards infinity of some constant is literally just that constant. So for this first one, we just have 2. For this guy, we also saw that from our theorem, it'll go towards 0. This limit as x goes towards infinity of 1 over x, that's just 0. So really, this minus sign we can drop down as well. So really, we have 2 minus 0, which just comes out to be 2. And we can even see just from our graph that as you go towards infinity of our function, it is in fact approaching that limit of 2. All right. Now when we're looking at the limit as x goes towards negative infinity of 2 minus 1 over x, well, we can go ahead and apply that limit to both of these. So we have then the limit as x goes towards negative infinity of that constant 2 minus the limit as x goes towards negative infinity of 1 over x. Simplifying things out, again, back from our theorem, it said that anytime you're taking the limit as x goes towards infinity or negative infinity of a constant, it's literally going to be that constant. So we just end up with 2. We're going to drop down that minus. And then the limit as x goes towards negative infinity of 1 over x, well, we saw from our theorem that is just 0. And there it is. So we end up then with 2 minus 0, which is just 2. By the way, another really quick reason why this works, why this limit as x goes towards negative infinity of 1 over x, why that's 0. If you imagine throwing in infinity or negative infinity, doesn't really matter, in the bottom here, well then you end up with 1 over negative infinity. And on the bottom you have some immensely large number. So anytime you have that in the denominator for a fraction, so some number on top divided by some massively huge number, it's going to be very small. So that's why that limit is going to be 0. So again, though, that is example 1 from our 1.5 number 2 set of notes.